adesso io...
C'è un microfono.
Ma chi ha... No, non c'è problema, ma il microfono dove?
You have your microphone?
No, I have no microphone.
Scusa. Questo? Quindi parla. Shh. Scusa. Ma questi funziona? Funziona? Marco, funziona questo? Ma. Che faccio? Scusa, parto io? Sì. Well, you can sit down. We had the pleasure, the honor, the privilege to welcome to Charles Duke in the Faculty of Civil Industrial Engineering. Each of us probably look at the moon and dream, I would like to be there, probably just for some minutes, just for 1 hour. Well, Charles Duke really spent a lot of hours there many years ago in the program of Apollo 16 in the April of 1972, and he arrived there with a colleague, John Young, and they spent about 70 hours there, and they walk on the surface of the moon for 20 hours. I think that this, of course, is a very extraordinary, a unique experience, and this means that Charles Duke is really a unique person, because the person really is the experience that spent in his life. So really a very great pleasure to welcome to Charles Duke in our Faculty of Civil Industrial Engineering, where the study of aeronautic and aerospace engineering is an excellence. We have a long story. We have a connection involved with NASA, with the U.S. Embassy, about many chances to develop together some important events. And so this is one of these events very, very important, because really Charles Duke is a unique person. I would like to thank my colleagues from aeronautical and aerospace engineering, in particular the colleague there, Marcello Nofri, because of course the cooperation, the synergy about all the people involved in aerospace engineering make a great results for the faculty and for the course in this area. Thank you very much.
Thank you, Professor. Thank you very much.
Take the mic very close.
Okay. How's that? Good. Well, thank you very much for the opportunity to give you a 1-hour lecture. I was going to the moon for 11 days, and when I got back, it took me 14 days to tell my boss what it was like. So in an hour, we'll sort of sneak in the highlights, okay? I'd like to first introduce my wife, Dorothy. We're delighted to be back in Rome. This is the first time in a long time since I've been here. We've been in Milano, we were in Bologna, we're here, and then we're going to take a few days holiday, go to the Amalfi Coast over the weekend. So we look forward to seeing all of your country, and thank you for coming. I would like to say thank you to Agape Italia, who has invited us here. To give this lecture, and for coordinating with the university to have an opportunity to share my experiences. Let me a little bit about background. I was a graduate of the United States Naval Academy. I fell in love with airplanes when I was at the Naval Academy, and so I became a pilot. 1957, I was in flight school, when the Russians launched Sputnik in October of 1957. To me, that was the beginning of the space age. 2 years later, I was in Germany flying for 3 years from 59 to 1962, and during 1959, of course, the first cosmonauts and astronauts were selected. We're going to actually send people into space. And 2 years later, in 1961, Yuri Gagarin was the first in space, followed by Alan Shepard in May 1961. 2 weeks later, President Kennedy announced we're going to go to the moon, we're going to land on the moon, and we're going to return safely from the moon by the end of 1969. To be honest, as a young fighter pilot, I said, yeah, sure, we're going to land on the moon. We had 15 minutes experience in space. I recall most rockets back in those days were 5, 4, 3, 2, 1, blow up rather than lift off. It was a lot of accidents. We had a lot of failures. But fortunately, we worked hard. We had 400,000 people involved in Apollo during that time. We had a good budget, political support, and so in July of between 1961 and 1969, I went to MIT for a master's degree in aeronautics and astronautics. I then went to test pilot school in California, where I was encouraged by my boss to apply for the space program. I applied for the NASA in 1965 and was selected with a group of 19 men in April 1966. And so we moved to Houston from California, and I started my training. It turned out in all of Apollo, from beginning of Apollo to the end of Apollo, we had 9 missions to the moon. We had 6 landings on the moon during that time. One scheduled to land but didn't because of an explosion, Apollo 13. So we ended up with 12 men stepping onto the moon. 24 of us went to the moon in Apollo. I was well, let me say I made a transmission to Apollo 11, 30 seconds. It meant they had 30 seconds to land. And about 13 seconds later, I heard contact engine. And sure enough, with 17 seconds fuel remaining, Neil Armstrong landed on the moon. I was the backup crew for Apollo 13, and a week before the flight, I get sick, I catch measles, and exposed everybody to the measles. That required a crew change, so a week before the flight, the man I trained with took Mattingly's place, and they swapped out 1 for 1 on that crew. A very challenging time in mission control to get that crew back safely. It was really tense for the first 20 hours. I didn't think we were going to make it. We didn't have enough oxygen. We didn't have enough electrical power. but we got very, very smart, and we learned how to power up, power down, and so we got back safely. And a great accomplishment on the behalf of Mission Control. Mission Control had a role in just about every Apollo mission to save the day, if you will. And that was true on our flight. The rotation in Apollo was if you were backup crew, and then 3 flights later you flew. So back up on 13, I ended up flying on Apollo 16. As you heard, we launched in April 1972. We trained for 2 years. It didn't take 2 years to get ready, but that's just the way the schedule went. Being an astronaut was not a very glamorous job, really. You watch Martian, and you watch Gravity, and you watch that, and everybody's floating around having a great time. But floating around having a great time, there's hundreds of hours of training goes into that time where you're outside, making it easy, but you've trained over and over and over again. So there was a lot of training. I spent equivalent of a master's degree in geology, learning what rocks to pick up on the moon. We had all these science experiments that we had to learn the science behind what we were doing. We had to learn how to fly the spaceships, the spacecraft. You couldn't go to the airport and rent a spacecraft to learn to fly. You had to do it in a simulator. So I put 2,000 hours in the simulator learning how to fly the lunar module and the command module. Of course, in Apollo, we had 2 spacecraft, 3 crew. We all flew together to the moon in the command module. Once we got in orbit around the moon, 2 of us got in the lunar module. We landed, and while the other astronaut, in our case, T.K. Mattingly, he orbited the moon while we were on the surface. Our mission was scheduled for 12 days. It turned out 11 days because we had some problems. Mission Control got very nervous and decided to bring us home early in case the thing didn't work on the way out of orbit. They had another day to figure out what to do. There were some situations on Apollo, for instance, on the moon, if the engine didn't work, you had an emergency procedures that you accomplished. But if that didn't work, what do? Well, you power down and make it last as long as possible, and maybe somebody would come up with a good idea and to get us off the moon. There was no rescue. You had to get off the moon by yourself, or you were eventually you would die on the lunar surface. People wondered, did we have any way to commit suicide in case we were trapped? It's very easy to kill yourself on the moon. All you have to do is open the door without your spacesuit on, and you're dead. In spite of what some of the Hollywood movies show, you don't float around in space without a spacesuit and expect to stay alive. So anyway, we had no failures that resulted in death. We did have some problems. I've got a PowerPoint that I'd like to start with, and somebody can flip it for me. I want to describe as much technical side, since you're all engineers and studying to be engineers. Go ahead, through this first one. Oh, yeah. Okay, let me move out so I can see better. Okay, we'll go to the third slide. This is our crew. That's what I looked like in 1972. Of course, that's a long time ago. This is John Young. He was the commander, and it was his 4th mission the second mission to the moon. He was on Apollo 10. Didn't land, but now he's on his second flight to the moon. And this is T.K. Mattingly, who was originally scheduled for Apollo 13, got bumped off the crew and joined us for Apollo 16. Next slide. This is all the missions to the moon launched on the Apollo Saturn V rocket. It was a big rocket. From the bottom to the top was 110 meters. It was 10 meters in diameter and weighed 3 million kilograms fully fueled. And we're at the top up here in the command module. This little white thing was called a white room. So when you got strapped in, you took an elevator up to the top of the vehicle, walked across the swing arm to the white room, and then you started getting into the spacecraft. There were 5 guys up there to help you get strapped in, and once they closed the hatch and sort of waved goodbye through the window, they were out of there, and you were there for about an hour before liftoff. Next slide. Here's our liftoff. The Saturn had 5 engines. The total thrust was 3.5 million kilos of power to lift us off. So we had 3.5 million pushing 3 million. So the ascent at first was very slow, but very vibration. You got a 110-meter long aluminum structure. The engines move at the bottom, and that vibration is translated to the spacecraft, and there's a big lateral vibration during the first stage. The first stage is from here down and lasted for, on our flight, 2 minutes and 40 seconds. When it shut down, then the second stage took you almost into orbit, and the third stage accelerated and pushed you on to orbital velocity. We left the Earth over Australia. We accelerated to 40,000 kilometers per hour, and we were on our way to the moon. Shortly thereafter, we turned around. Next slide. And this is the view of the Earth we had. You could see almost the whole circle of the Earth. Here's the Arctic Circle, Canada, the United States, the south central United States. Here's on this side is the coast of California, Baja California, Mexico, the Yucatan, the southwestern United States. Here's Florida, and the southern part. This is the northern part of South America, and then a lot of the eastern Pacific Ocean. And that jewel was, this is about 30,000 miles away, and there it is, just suspended in the blackness of space. The sun always shines in space, of course, so there's no night. And when the sun shines, you don't see any stars. In spite of what Hollywood says, you don't see any stars. So you look out the window, and you can see the moon, you can see the Earth, and you can see the sun. Those are the only 3 objects you see on the way to the moon, because you have 3 days of daylight. And so since there's no atmosphere, you look out and you just see the blackness of space, except for those 3 celestial objects. You might wonder, well, how do you tell time? There's no sunrise and sunset. Well, in all of the spacecraft, at least in the U.S., when you leave Earth, a clock starts in the spacecraft. And it starts to count ground elapsed time. And it goes 1 hour, 2 hours, 3 hours, 4 hours. And so your flight plan and your activity is based on that clock. And so let's say 3 hours and 15 minutes, start the engine, leave Earth orbit. 16 hours, go to sleep. 24 hours, wake up. So your whole flight plan is based on that clock. And then it can be modified by mission control, but your time out in space is on the clock in the spacecraft. There was no evidence of human life from 30,000 kilometers Here is the spine of the Rocky Mountains in the western United States. Okay. This is just a map of the moon. The green are the landings of Apollo. The first landing was here, Apollo 11, on Mare Tranquillitatis. We were the fifth landing, and we were southwest. The center of the moon is in this position right here. So we were about 15 east and about 10 south. And from here to here was about 2,500 meters elevation change. We were up in the mountains of the moon for our landing. The farthest north was up here with Apollo 15. The farthest east, Apollo 17. The rest of the missions were on the western side of the moon. This flight right here, Apollo 12, landed next to this Surveyor, which was an unmanned spacecraft we sent to the moon. One of the problems, debates before we landed on the moon was 80 meters of moon dust. So when you land on the moon, you're going to sink out of sight in the moon dust. Or so the theories were by some people. Other people said, no, it's not going to work that way. So let's send an unmanned spacecraft. So we sent a spacecraft Surveyor. It landed. We turned on the TV, and there it was sitting right up on top of the lunar surface. The dust on the moon in our area, in some areas, was more than 10 meters deep. But a couple of centimeters. So everywhere you walked up on the moon, you left your footprints. You never worried about getting lost because all you had to do was turn around and follow your tracks back. Okay, next slide. We're in lunar orbit now, and here's our spacecraft. It looks upside down, of course, but there's no up or down in space. To us, we were right side up. Here is the door. No, the door is here. Here are the two windows. And when you're on the moon, you open that door, which was less than a meter, maybe 3/4 of a meter in diameter. You climb down the ladder onto the footpad. The vehicle weighed, let's see, about 9,000 kilograms at this point. And the car was folded up and bolted over here. And then this is a equipment storage here. Next slide. We're now on the lunar surface. We landed in Descartes, and it was a big valley about 10 kilometers across. And during our 3 excursions on the moon, we were to explore this valley. The first excursion took us west about 2 kilometers. The next excursion took us to the top of this mountain here, we call Stone Mountain. And from where we landed to the top of the mountain was about a little over 4 kilometers. And we drove our car up to this point, which gave you a fantastic view of the moon. The moon is covered with dust, very fine like powder. It's pulverized rock. Since there's no atmosphere on the moon, there's no wind, no rain, no organic, nothing except just the rock of the moon that's been pulverized and cratered by meteor impacts. There was some volcanics on the moon. The dark areas of the moon are all volcanic, but where we landed had very few volcanic rocks, mostly igneous rock, very, very fine-grained, which was very exciting to find. During our stay on the moon, next slide, notice how bright it is in the sunlight, but how dark it is in the shadows. And as we stood on the moon, as we landed on the moon, the sun was in the east, about 15 degrees above the horizon. And the surface temperature on the moon was about 30 degrees centigrade. When we left, 72 hours later, the sun had moved to about 55 degrees elevation, and the surface temperature average was about 115 centigrade. But your spacesuit protects you from that heat. What you really worry about is the body heat inside. It's like working in a refrigerator in a spacesuit, and you need to eliminate the body heat. So we had a very efficient system called a liquid-cooled garment. Next slide. Here I am saluting the flag. A lot of people say, well, wait a minute, this is all hoax. You didn't really land on the moon. There's no atmosphere on the moon. Why is the flag out there waving like that? Well, the flag's not waving. It's held out by an aluminum rod, and it was vacuum packed for 6 months. And so when I tried to unfurl the flag, I couldn't get the wrinkles out. And they didn't give me an iron to iron out the wrinkles. So that's why the flag looks like it's flying. Next slide. Okay, this is our car. This car is an electric car. It was folded up and bolted to the outside of the spacecraft. And so when we got there, we had to deploy the car, which was almost not automatic, but it was it unfolded all by itself like a landing gear on an airplane. This is the front of the car. John Young, from where we were on the moon, the Earth was directly overhead. So to have TV on the moon, that antenna had to be pointed directly at the Earth and remain there. And so then we turned on the TV, and we had television from the lunar surface. It was an electric car. There were 2 batteries up here that operated, powered the car. 28 volts was the voltage. Each wheel had its own electric motor. And John sat in the left seat. I was in the right seat. And here was the controller. He drove. I navigated. I had a set of maps. Here's some maps here. And I had to go get us from point A to point B during our excursion. You might wonder, what's direction on the moon? There was no magnetic field. So the shadow was always west. The sun was, we assumed the sun was going to be in the east. The shadow's west. So we turned the car down sun, and we had a directional gyro. And we turned the gyro until 270 west was at the top of the gyro, and that was our direction. And then we had a odometer in one of the wheels, and it measured distance. So our maps were 220 for 4 kilometers, stop, and that's your stop. The car could go, let's see, the car could go about 100 kilometers, but if you drove that far and the car broke down, you had to walk back, and impossible. So about 5 kilometers was the maximum you could walk back before you ran out of oxygen. And so the object was to go as far away as you could, 5 kilometers, start there, and then work your way back in case, so you'd have maximum oxygen and electrical power if the car broke down and you had to abandon the car. Next slide. Here's a good view of the lunar module. We lived in this upper portion here called the ascent stage. Here's our car. I don't know which, I can't tell which one of that is. Here's the ladder. From the footpad to the door was almost 5 meters. You can see some of the footprints up here, and everywhere we left the rover tracks or our footprints. Go ahead. Okay, here I am west of the lunar module, about 1.5 kilometers. The car is on the east side. I call this crater Plum Crater, and it was about 15 meters deep. And if you fell in that crater, you were trapped. You couldn't get out, so you had to be very careful where you walked up on the moon. We had no rescue to pull us out of big craters like that. no lifelines. If you fell in, you were on your own. But trying to get out, as you tried to climb out, it sloughed in. And we knew that was going to happen, so we had to be very careful. Next slide. Next slide. Here I am next to the back of the car. This was all geology experiments. You can see we turned around and run over some rocks and parked the car. And back over here is the lunar module out in the middle of the Cayley Plain or the Descartes Highlands. And we're actually up on almost the top of that mountain I showed you a moment ago. If I go through all this, I got a lot of slides. I'm going to stop here, sort of give you an idea of what the moon looked like. As we stood on the moon, as I said, the Earth was directly overhead and always daylight, so it was just blackness of space. You didn't see any stars. The only object you could see, of course, is the sun and the Earth directly overhead. And people said, what did the Earth look like from the moon? I said, well, I really can't tell you what it looked like because I'm standing there and the Earth is directly overhead. And when you look up in an Apollo spacesuit, you're looking at the top of your helmet. So one time I fell over backwards and, there's the Earth right out in front of me. So I'll show you that fall later. Let's go to your demonstration. Now, we've got a great demonstration here of what it actually... y'all can come in and take your spot here if you want before we get going. Sorry you got to sit on the floor, but... Yeah, sure. Come on in. This is a demonstration of what a landing looks like from the from the cockpit. Is this Apollo 11? Okay, so we're coming in. Imagine you're landing with Neil Armstrong on Apollo 11. Before we get started, let me describe. This is our attitude indicator. This is a lateral velocity, forward and aft velocity. This is our computer that we had. We had no digital readouts. All we had was numbers. And you had to memorize every computer program. What's that information that's being displayed to you? The computer had, this is P66. We had 3 landing programs. We had an ascent program. We had a rendezvous program. And we had a navigation program, all in 80K memory. Amazing that we could do it with 80K, but we did. Today, my cell phone has 200,000 times the memory of this computer. So big technological jump. And this is altitude, and here's rate of descent. So we're starting at about 600 feet, like 200 meters, and we're at about 6 meters rate of descent. So we'll start as we come in. Now, go ahead. And so this is what the commander sees. This is called a landing point designator. And the computer told you to look through certain figures, and then you would see where you were going to land if you didn't take over manually. Unfortunately, we had 11 targeted into this big boulder field, a lot of big rocks. He couldn't land, so he levels off at about 400 feet and flies over this these rocks, and then gets beyond. So now he starts down, but that took a lot of fuel, and so more than we budgeted it. So now we're minimum fuel. We're still about 200 feet off the moon, descending at about 8 feet per second, a little over 2.5 meters per second. And so he picks out a landing spot and begins to maneuver, and he keeps the lateral and horizontal velocity almost nil. So now we start down, straight down like a helicopter. We're coming down at 80 feet, 20 meters or so, at a few dust, and then the shadow of the lunar module comes in, and as we get down, you start seeing the shadow appear in the top of the window. So it was critical fuel at about 20 feet or so. He's got his landing site picked out, and then the light comes on, contact, and you shut the engine and you drop in the last meter or so. So that was their landing. Our landing is similar. I don't have the whole landing, but if you want to, all of the lunar landings are on YouTube. And so you can go to YouTube and Apollo landings or whatever, lunar landings, and every flight gives the whole sequence of the descent, gives the conversation from mission control to the crew and from the crew themselves. And so it's very, very well done, taken from the NASA actual footage. This was an excellent little demonstration, and you could do this manually on this simulator, but I guarantee you, you're going to crash the first time you saw it. Try it. Okay, let's go to the DVD now. Now I've got a 15-minute DVD that's silent that I'll narrate, and then after that, I'd like to open it up for questions, and then we can. I'll try to answer some of your questions. This, as I said, I'll narrate, and we start at Florida at Ascent, and we end up at the end in the Pacific Ocean. Yeah, ready. So hopefully it'll work. MPG, yeah, that's it. Yeah. So while we're waiting for this to get queued up, let me say, as we were on the moon for 72 hours, and so we divided our 72 hours up into 3 24-hour periods. So we had a rest period for 8 hours each day. We ate one meal. We ate one meal while when we woke up. We suited up, and to get ready to go outside, it took about 3 hours to get ready to go outside. The longest so each flight had its own insignia. Is it going now? Okay. Okay, here we go. So let me get out of the way here so I can narrate. Okay, we're at Kennedy Space Center, Florida, and here we go, ignition. It took 8 seconds from the start of ignition till you started to move. And the vehicle was checked out by launch control, and then they released it, and you started to move. I explained the power of the engines. The white stuff falling off was ice. The fuel is very cold, so we had several tons of ice. And you can see the big chunks falling off, and by the time we had the first few seconds, all the vibration was such that the ice was all gone. We cleared the tower. It took 8 seconds to clear the tower. First stage is here down. And in our mission, it lasted for 2 minutes and 40 seconds. It took us to an altitude of about, if I remember, 50 kilometers, a velocity of about 12,000 kilometers per hour. Then the first stage fell off, shut down, if you will. The first stage shuts down on an acceleration. When you got to 4.5 Gs, it shut down. You didn't want to land with, didn't want to shut down with fuel depletion because things got very unstable in these big rocket engines. Of course, as you got higher and higher, the plume expands, and actually the engines became more efficient the higher you got. This is a camera from the launch center taking our picture. First stage shuts down. It was like a big explosion. You went from 4.5 times gravity to 0 at the snap of a finger, and it falls away. You can imagine the explosive charge to separate a 10-meter piece of aluminum. It was a big boom, and this is what it looked like from Earth. And the first stage falls away. This was called the inner stage, and this is the Atlantic Ocean, clouds. Florida's back over here. There's the descent first stage falling back in. Most of it burned up, but they did have recovered now, 40 years later, some of the main engines. Here's a view of Earth I took again. Now, U.S. is this way, so here's California. Off to the left is the Arctic, northern Arctic up here, and then down across to Yucatan. Here's Cuba, and Florida is right in here. Inside the spacecraft, it was very small. 300 cubic feet was our volume inside. Mattingly's exercising. It's very easy to lose objects in zero gravity. Things just float around. In fact, on the second day, Mattingly lost his wedding ring. Long story, but it took us 7 days to find that wedding ring. Very interesting story how it was found. If I have time, I'll share that. That's a flashlight. It's impossible to get things steady in zero gravity. We had food, came in plastic bags, dehydrated. This is not Apollo, it's shuttle, but this is grape juice. Grape juice. It shows you what liquids do in space. Takes sphere, in it goes. And now we have a banana flying through space. And a little gyroscopic action there to stabilize it. We arrive at the moon. 72 hours after we left Earth, we arrived at the moon. Now, John and I are in the lunar module. He's looking out of this window, and here's his main window, and here's mine. Actually, this is inverted. His should be on the, because I'm on the left side. And so it looks right. But when we landed, I'm on the actually right side. Now I'm left here. The door, the spacecraft, the command module stayed in orbit. It had a whole suite of experiments that he did while we mapping the moon, other experiments like that while we were exploring the moon. We had a major problem with our main engine in this spacecraft, so delayed our landing 6 hours. And here is one of the views of the Earth that we had. 2 kilometers above the moon. These craters are 500 meters in diameter. So we now, about 20 meters off the moon, we start blowing the moon dust away. John had picked out a landing spot. The shadow comes in, and we slowly settle down, and we have that contact light, shut the engine down, and drop in the last meter or more. You didn't want to land with the engine running because you couldn't see beneath you. If you landed on a big rock and plugged up the engine, it blew up. So that wasn't very smart, so we shut the engine down and we dropped in. First steps on the moon. We didn't have any big speeches like Neil Armstrong. I think, Yahoo, here I am on the moon, you know. This is a camera. We had no digital cameras back then, so we had to put the film on the cameras. And this is a film magazine. I'm trying to blow the dust off of but it didn't work, of course. You can't blow dust through your visor. So we had 2 of these cameras that we took about 2,000 pictures over the 3 days we were on the surface. Again, this is a TV picture recorded in Houston. Here I am to get John, as he comes out, to get his picture taken. As a result, he gives me a big leap for joy and a big salute. We swap places, and then I get my picture taken. Now, here I am. My most embarrassing moment is coming up. I'm walking out with $10 million worth of moon experiments in this little thing here. And as I jog out, they fall off. And well, I ruined the whole mission, you know. But in the 1/6 gravity, they weren't damaged, fortunately, so we were able to get them all deployed. Here's John just showing how you could run across the moon. The suit was very stiff, and you couldn't bend over, you couldn't lift your leg to a horizontal position, but you could operate up in the arms good. I'm drilling a hole into the moon while John is working on the power station, we had one failure in one of the experiments due to an electrical failure. I'm taking a 16 millimeter movie of the car underway. You see how rough it is and what a rough ride it was on the moon. No roads on the moon, but no traffic either, so you just sort of bounce across the moon. Here I am doing an experiment called a penetrometer. It goes all the way in, so I fall down, and to get up is easy to do, but we'd practice this, so a push up, and that didn't do it, so you rock up again, and you almost make it, and then one more, and we're up. We normally collected moon samples together, and over 3 days we collected 98 kilograms of moon rock. But sometimes we did it separately, and as a result of that, next scene you're going to see me trying to do it by myself. I had a shovel, and I flip up this rock, well, I didn't make it, but I had determination. So this time, here's this rock, comes up very gently, and I catch it in my right hand, but drop the bag I was putting it in. So we had a lot of little setbacks like that on the moon. We had big rocks, but the biggest one we had was about the size of this room. We called it House Rock. It was on the last excursion to the north of our landing site, about 4.5 kilometers. And so my heart's pounding. Fortunately, I responded by rolling right and broke my fall on my right side. But I'm laying on my back, and John's, "Are you okay?" And I said, "I think so." And he helped me up. My heart was pounding. and you could hear the pumps running. The pressure was normal, so it looked like I was okay, and sure enough, I was. I didn't break anything. But I found in my life, the older I get, the more I do things that I shouldn't be doing, the more trouble I get in. So don't do things in space that you haven't practiced. So we left the car on the moon, and off we go as the TV watches us. The TV camera was controlled by an engineer in Houston, and so he could move it, pan it around, zoom in out, elevate it, and so all we did was turn it on, and then he operated it. The battery's dead on the car. It's still there. If you want to go ride in the car, take a battery with you because it's dead. Here's rendezvous from an altitude of 100 kilometers. We start back on the 8th day of the mission, and then we hit the atmosphere. This is Fireball outside of the spaceship. As we hit the atmosphere at over 41,000 kilometers per hour. So you had a big fire around the spacecraft as you plunged into the atmosphere. Maximum deceleration was 7.5 times gravity. So you're going in backwards, looking out from where you came, and you see the spacecraft maneuver right and left like that. And what's happening, it's controlling its descent to hit a spot in the Pacific Ocean. Apollo had no wings, but it had lift like an airplane because the center of gravity was offset from the center of the heat shield. So it generated lift. So you came in, lift vector up, and then you got captured, and you started to maneuver back and forth. At 7,000 meters, the parachutes start to deploy, and at 3,000 meters, the main parachutes open, and when you see those, you breathe a sigh of relief. You're going to land safely somewhere. And fortunately for us, it was within a couple of kilometers of our landing spot. Helicopters were there. The ships were all back in here, and started out 3 million kilograms, and now we land with about 6,000 kilos is all that's left, including us and the moon rocks and all the experiments results that we brought back with us. So we had splashdown in the South Pacific, and that was the I was the 10th man on the moon, and there was 2 more, Gene Cernan and Harrison Schmitt, and then Apollo was over December 1972. So long before you all were born, Apollo was ended, but it was a great moment in the history of human spaceflight. I think 1,000 years from now, one of the few things that might be remembered is we went to our nearest little heavenly body called the moon. And so it was a successful program. As I said, I'm not sure I said it, this is my 3rd talk today, but we had 400,000 people working really hard to get us to the moon. So we didn't do it by ourselves. The mission was helped by all of these people involved, technicians, engineers, even the janitors. My wife janitor. He says, she said, what is your job? He said, my job is to put a man on the moon. And that's a good attitude for your people to have in working, because you depend on their work to keep you alive. I've got a website called charlieduke.net. If you want to go there, there's a lot more on my website about our flights. There's also a website called Apollo Lunar Surface Journal that has all of the transcripts from all of the flights cataloged. We have the Apollo Image Gallery. All of the photographs are there, some in high resolution. It's all available. You can download it. You can't use it for commercial purposes, but Apollo's free. We also, we've written a book about this experience in our lives. It's called Moonwalker. You can get a digital edition on Amazon, an ebook, if you will. But if you want a printed copy, you got to order one from our website. Also, we have some handouts here that Agape are here, and it's in Italian, and it's sort of I've got a little pamphlet called Walk on the Moon, Walk with to the moon, but there's a result of needing a balance in my life and needing to, and God brought that balance. Any questions before, I think we're over time, but any questions before we depart? Now I just spoke to, thank you. Yeah, okay. Thank you. Thank you very much. Thank you. I appreciate your enthusiasm. I don't know what field you're going to go to in your career, but hopefully yours will be as successful as mine was. And I just encourage you, whatever life brings to you, study something and do something that you enjoy doing. I enjoyed engineering. I enjoyed aviation. Had I never gotten selected as an astronaut, I would have had a successful career in my life. So fortunately, I did get selected and got to experience this tremendous experience of being one of the 12 men that walked on the moon. By the way, of the 12 that walked, 4 have died since that time. The last to pass away was Neil Armstrong as a result of complications from open heart surgery. I'm the youngest guy on the moon, from that walked on the moon, and I turned 80 this month. So we're all over ancient. Yeah. I told NASA, if you need by the way, physically, I can pass the physical. But NASA says, don't call us, we'll call you if we need you. So, yeah, I don't think they're going to call an 80-year-old to go to the moon, even if we had a program. Thank you very much. God bless you all. Thank you.
I know that many of you have not much time, because I think that each of them want to make you some question. But of course, we can start. Somebody can start. Oh.
Yes. On Apollo, you had 2 crews in training. One was called a prime crew. They would actually fly the mission. If they got sick or got killed in an accident, the backup crew would take their place. Well, I'm backup crew, and I get sick. I catch the measles. So I expose everybody to the measles. And one of the men who was supposed to fly had never had the measles, so they took him off the flight and substituted a guy named Jack Swikert, who I had trained with. That man came back and on our flight, and we ended up flying together on Apollo 16. If you saw that movie, by the way, Apollo 13 movie was very, very good. It captured the drama, it captured the tension, and the chronology of the troubles we had in on Netflix or on the web somewhere, and I would recommend you see it. It was the closest to real space flight action that you can that we could have. Any other questions before we go? Oh yeah. What did I feel when I put my first steps on the moon? My emotions were, you can't feel anything. It's the emotional side that you're experiencing. And as I stepped off the landing gear onto the moon, it was, I'm on the moon. I just had this excitement that I'm on the moon. And everywhere I looked, I had this thought, nobody's ever been here before. We're the first people to ever step on this part of the moon. And so it was a great excitement, a great adventure, no anxiety, no fear. It felt like we belonged on the moon, and so we enjoyed ourselves. We had fun on the lunar surface. So it was more a fun adventure than anything else for me. Yeah. Mm-hmm. What was it like coming back to Earth? At first, when we got back, of course, you were very enthusiastic, very excited, and you had such an adventure, you wanted to do it again. So I volunteered to be on the backup crew for Apollo 17. And if they broke a leg or they had an accident, I'd get to go again. After that was over, I went to work on Space Shuttle. And one of the big problems with all of us, I was 36 years old when I got to the moon, and I was at the top of my career. The rest of your life. Yeah, that drive that took me to the moon was still inside. And it was difficult to fulfill that drive with a program that was 8 years, 9 years before we would have another flight. And so I left NASA thinking that, well, maybe making money would be okay and that would give me peace. But if you go to our website, you'll see this story. But we were having big problems in our marriage, and things were falling apart, no peace in my life. And eventually some friends invited me to a Bible study at a tennis club. And there I had this encounter with the Lord, and that gave me the peace and the direction and the purpose that I was searching for all my life. It didn't take the adventure away. It didn't take my science background away, but it gave me a purpose in life. I'm an investor in software companies. I'm also a lecturer for talk about teamwork, mission, outstanding performance, and delivering under pressure. As I said, Agape Italia is invited us, and I'd like all of you who are associated with this group, would you please stand up? And they're going to be here. We're leaving, but they're going to be around, and so. So, another question, or we go? Ready to go? Yeah. Would I like to go to Mars? If it were possible, I would go to Mars, but not on a one-way trip. Some people want to colonize Mars, just go and stay. I can't think of anything more boring myself because you're always in the same environment. You're always in a habitation module. You can't get outside except in a spacesuit. When you're on Earth, I think an adventure to Mars to go explore and return like we did would be a very challenging opportunity. But it's not possible for me, not only my age, I've retired, so I won't get to go. But your generation, I think, will go to Mars. And I think the human spirit is to go explore, to discover what's out there. And so hopefully some of you will get a chance to see the red planet and look back and you'll see that little blue dot out there, which is Earth. Any other questions? Yeah. Before going? Oh, excited. I was ready to go. You know, we trained for 2 years. Let's go. And I can't say I was praying, but I was in the launch, on the launch pad hoping, let's go. Don't stop. Let's go. And at least you got your chance once you left the Earth. So it was very exciting to have that experience. Yeah. The fear in the mission was I didn't have any except when I fell over backwards. It's sort of crazy to fear and worry because you couldn't do anything about it anyway. So why worry? Focus on your job. Focus on the procedures and the things that you needed to do to make it successful. When I did jump and fall over backwards, that was unrehearsed, and so I had a moment of fear. And the thought, emotion, if you respond with training, if you respond with panic, you're going to trouble. So if I'd have kept flailing around like that, I'd have been in trouble. But I said, do something. I rolled right, broke my fall, and bounced on to my back. But my heart was pounding. Am I okay? Fortunately, I was. But it was the only moment in the whole flight where I had a moment of fear. Yeah. Color on the moon, we had some Apollo 17 found some rock that had an orange color, but it was very rare. We had black rocks, we had white rocks, but mostly gray rocks, just shades of gray on the lunar surface. And so that was the only color. As we looked out from that mountain back across the valley, you could see the lunar module out there with its gold and other colors, and that was the only color you could see out there. Okay, thank you very much again. Great day. Thank you.
Thank you. Thank you to Charles Duke for his spectacular conference. Great views, great picture and movies. Something unique for many of us, and I think that in these wonderful full moon nights that we have in these days, we have not only to look to some romantic thinking, but also to what to do in the moon if you have 72 hours to spend there. So we have many ideas now, and we have to thank Charles for what he did and for what he showed us. It's an honor for Sapienza University to have you here. Thank you very, very, very much.